Okay, so today we're going to look at section 10.6 arithmetic series. So what we're looking at today is when we want to sum a series or sequence. So for example 5, 8, 11, 14 goes on. It's a pattern that goes on. But we want to sum up a certain number of terms and see how much they add up to. So this formula is in your logbooks. And it's the formula when you want to sum up a certain number of terms. So the sum of n terms of an arithmetic sequence is given by the formula Sn. So where n, it could be 5, you might just want to add up 5 of the terms. And then everywhere there's an n, you replace by 5. A again is your first term. And d is your common difference. Okay, so we'll do an example. Find Sn and hence S20 of the series. Okay, so again we look and we see, what do I do to get from 5 to 8? I add 3. What do I get to get from 8 to 11? I add 3. And what do I get how do I get 14 from 11? I add 3. So A is my first term, which is 5. D is what I'm doing each time, which is plus 3. So the first part of the question just wants us to fill in Sn and leave n as it is, but fill in A as 5 and D as 3. So 10 plus, let's multiply 3 by n is 3n, 3 by minus 1 is minus 3. So then just tidy that up. 7, because 10 minus 3 is 7, plus 3n. And you can leave it like that, that's Sn. Okay, and then they wanted S20. So now we're going to, anywhere there's an n, we're going to put in 20. So 20 over 2, 7 plus 3 times 20. Into your calculator. And the answer is 670. So S20 is 670. And what that means is that when I add the first 20 terms, they add up to 670. Alright, so we'll try another example. Find Sn and S10 of the following series. So again, A is 1. What am I doing? I'm adding 2. What am I doing? I'm adding 2. What am I doing? I'm adding 2. So D is 2. So Sn is equal to n over 2a plus 2a plus n minus 1 times d. So Sn is equal to n over 2, a is 1, d is 2. So 2 take 2 is gone, so you're just left with 2n. So there's your Sn. And then S10, 10 over 2, 2 times 10. So, your answer is 100. So your first 10 terms would be 100. And if you want, you can always check, like your pattern is this, so you know how it continues. It continues going up in, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's your first 10 terms. If you add all of them, so 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 15 plus 17 plus 19, you get 100. So that's all this fancy formula is doing. It's just adding them. Okay. Okay. We'll do one more example, which is slightly different. So given that the arithmetic sequence 5 plus 7 plus 9 plus ... that means it continues on. If Sn is 192, find the value of n. So this one is telling us, when I add up so many terms, I get 192. How many terms did I add to get that 192? So again, you're starting with your formula, but this time we have something different. We have the answer and we're looking for the n. Now we can get our A. A is the first term, which is 5. Again, this is a plus 2, so D is 2. So in this question, we know 192. We don't know n. We know A is 5. Sorry, that's a minus there, not an equals. and we know D is 2. So 192 equals n over 2. So let's work out, simplify the bracket. So 10 minus 2n plus 2. So 192 equals n over 2. So 10 plus 2 is 12. Okay, and then you can do it one of two ways. You can bring over the 2, or you can multiply the n over 2 by everything. So n over 2. So you can't put n into your calculator, but you can put 1 over 2 multiplied by 12 and you'll get 6. Okay? And 1 over 2 multiplied by 2 and you'll get 1. And there's an n there and an n there, so that gives you an n squared. Okay? Bring everything to one side. So you have 1n squared. Bring this over, it becomes a minus 6n plus 192 equals 0. So this should look familiar. Okay? This is our quadratic. It's got an n squared, an n, and a number. So we're going to use minus b. Okay, so a is equal to sorry, that should be a plus. So that wasn't a minus, it's a plus. Plus 2n. So then that's a plus 1n, and this is 10. Sorry, let's go back up there. I made a mistake. So that form, I just wrote down the formula wrong. I put a minus there instead of a plus. So let's just fix this up. Okay. Okay, so 2 by n is 2n, and then 2 by minus 1 is minus 2. And then 10 minus 2 is 8. Plus 2n, and then a half multiplied by 8 is 4, and a half multiplied by 2 is 1. Okay, so just the signs are going to be slightly different here. So 1n, sorry, that's 1n squared because there's n and n. So then 1n squared plus 4n minus 192 equals 0. So this and this stay at this side, and this comes over and becomes a minus. Alright, now, so it's an n squared, an n, and a number. So whenever we see that form, we should be using minus b. So your a is the number with the n squared, which is 1. Your b is your number with the n, which is 4. And your c is a number on its own, which is minus 192. The formula is minus b plus or minus b squared minus 4ac all over 2a. So minus 4 plus or minus the square root of 4 squared minus 4ac all over 2a. Okay, so we're going to do the plus version and the minus version and just get our two answers. So minus 4 plus the root of 4 squared minus 4ac. Oops, sorry, I should have started with the fraction. So minus 4 plus the root of 4 squared minus 4 ac all over 2a. So n is equal to 12, and then just arrow back through and change the plus in front of the square root to a minus for your other answer. Or n is equal to minus 16. Okay, so we're talking about term numbers. So we can't add minus 16 terms, so this is not a solution. So your answer is n is equal to 12. So S12 would have given you 196, which means if I added 12 of the terms, I'd have got 196. Okay. So exercise 10.6, page 293. Try questions 1 to 5. Alright. So they're getting SN and S8 and S10 and stuff. There isn't actually one of the last example we do. I'll do another example like that tomorrow where we have to use the minus b before you have to do it. Okay.